welcome to the extension. Seems like you're already confident on the other material. So you guys are going to learn an ACT skill, combinations and permutations. You might learn this a little bit in Algebra 2, but this is one of those ACT topics that's always on the ACT, but we might not always get to it in our class. So you're going to learn it now. And the reason we need to do combinations and permutations are for questions like this. You have 12 folders that you need to organize in your filing cabinet, and you want to know how many different ways can you sort the 12 folders. As you can always change which one goes first, second, third, fourth, then you can change it up again, then you can change it up again. There are a lot of different ways that you can put those folders in order. But since I see I have 12 folders, and I'm going to use all 12 when I sort them out, you're allowed to do something called 12 factorial. Oh my God, is that an exclamation mark in math? What does that even mean? 12 factorial is that little exclamation mark, is a fancy way of saying 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You take that number and you start there and you multiply everything, but taking it down by 1 by 1 by 1 by 1. Because there are so many different ways that you can organize those 12 folders. Let's get a quick pause. Now, it sounds pretty annoying to have to go 12 times 11 times 10 times 9. So luckily, our calculators can do it for us. Go ahead and put in the number that we know, 12, and you're going to hit the math button, and that's going to be true on either calculator. You also see it's true over there on that blue one. And you're going to go over and let's make that a little more clear for you. There we go. You're going to scroll over until you get to PRB, which stands for probability. And you see, oh my God, is that exclamation point. Is that the same on the other calculator, Mr. Matthews?
Yep. So on this calculator, the math button is right here, and we'll scroll over to PRB. Under PRB, once again, there's that exclamation point.
And we're just going to hit enter. And now you have 12 exclamation point, and your calculator will do that math for you. So our answer is a really big number. Let's see. 1, 2, 3, comma, 1, 2, 3, comma. So it's 479,001,600 different ways that you could actually sort those 12 different folders if you just change up the order all the time. Now, we're going to have a different process when the combinations and selecting and ordering things are a little more complicated. Because here's a very real-world situation that we're going to need to know a little bit more than our previous problem. 10 students are in a race, and first, second, and third places will win medals. So in how many ways can 10 runners finish first, second, and third, assuming that there are no ties? Now in this case, the file folders, we were sorting all 12 of them. But we're not going to sort all 10 students. There are only 1, 2, 3 winners. And in this case, the first person is first, the second person is second, the third person is third, so the order matters. So when we are selecting just a small little group of the total and the order matters, that means we have a permutation, and we're going to use our permutation formula over here. And once again, we're going to use permutations because we're going to select a small group out of the total, and the order matters. So we're going to plug into the formula where the permutation is equal to n factorial divided by n minus r. And after you subtract that, we're going to take the factorial. So n just stands for what's the total that we might be choosing from. In this case, we have 10 total runners. So I'm going to write down 10 factorial because I have 10 total people that I'm considering. And in here, notice the exclamation mark isn't there, so I'm just going to use the number of 10 minus r. And r is just going to stand for how many you pick or select. So in this case, only 1, 2, 3 people are going to get a medal, only 3. So I'm only going to select 3 people. So I'm going to do 10 minus 3, and that's going to be an answer that I do the factorial with. So let's simplify this down. I still have 10 factorial divided by 10 minus 3 is 7 factorial. Now when I go to my calculator and I do 10 factorial divided by 7 factorial, that will be the number of combinations that we can have a first, second, and third place finish. So once again, we're going to go to the math button. We're going to go over, oh, I forgot something. I have to put in the number first. So 10. Then I'll go over to math. I'll scroll over to PRB and down to my exclamation mark. I'll hit enter. And it's 10 factorial divided by 7 factorial. So I have to go back into the math, scroll over again, go down to the exclamation point, and now I see 10 factorial divided by 7 factorial. So there are 720 different ways that those 10 runners could finish in first, second, and third place.
One.
All right, guys, so in this next problem, it's talking about a chemistry teacher, breaks her class up into 8 groups. Each group submits a drawing, and she will select 4 of the drawings to display. Okay, so if you want to pause the video and take a minute to read this whole word problem, you can. But one thing that you'll notice is, unlike the last problem, in this problem, the order doesn't matter, right? If she picks this one first and this one second, it doesn't matter because they're both going to be displayed. Okay, so when she picks them out, in this case, the order doesn't matter. And that is called a combination. Okay, in a permutation, the order matters. Right? First place, second place, third place, president, vice president, secretary, those sorts of word problems are a permutation because order matters. If the order doesn't matter, like in this problem, it's called a combination. Okay? And that means that we're going to need a different equation. So in this case, we're going to be using this combination equation. It's all the same variables, it just looks a little bit different. So to find a combination, we're going to use n factorial divided by r factorial times n minus r parentheses factorial. So this equation is exactly the same as the one that Mr. Bakke used. The only thing that changes is we have this extra r factorial in the denominator of our fraction. And once again, n is the total, and r is how many we select. Okay? And in this problem, the total number of groups is 8. So everywhere we see an n, we're going to replace it with an 8. Okay, so this is going to be 8 factorial. In the denominator, we have another n down here, so that's going to be 8. And then r is how many we select. And it says up here that she will select, it even uses the word, 4 of the drawings. So she's selecting 4, r is just going to be 4. So this is 4 factorial, 8 minus 4 factorial. And what we end up with is 8 factorial over 4 factorial, and then 8 minus 4 is just 4 factorial again. It will be multiplied there.
All right, guys, and here's the other calculator. And once again, the calculator is doing most of the heavy lifting for us here. So if we take a look, this is going to be 8, and then we'll go into math, over to probability, down to our exclamation point, 8 factorial divided by, oops, I'm sorry, that's a minus, divided by, I'm going to put this in parentheses just so we make sure we catch everything, 4 factorial times 4 factorial, and then we'll just hit enter.
Okay, and after we plug all that stuff into the calculator, we find out that this is 70. Okay, so if the order doesn't matter, there's only 70 different ways that she can select 4 of the drawings out of the 8.
So the challenging part of these types of problems is really deciding, is it a combination or is it a permutation? Because it determines the equation you're going to use, and they're different enough that your answer is going to be really different. So remember, combinations, the order It doesn't matter. Permutations, just like you went first place, second place, third place, the order matters. So when I read this, think to yourself, does the order matter or not? You put your ticket in a teacher box to go skiing. 50 tickets were placed in that box, and 3 tickets will be drawn to decide which students win that trip to go skiing. And how many different ways can you draw the 3 winning tickets? So ask yourself, does the order that I draw those 3 tickets matter? No. Because all 3 students that we pick out, they all get to go skiing. The first person doesn't get something special that the second and third person don't. The order doesn't matter at all. I just need to draw 3. So since the order does not matter, we have a combination problem. So we're going to substitute into the formula of n factorial divided by r factorial times n minus r factorial. And we'll have these formulas for you so you can organize this. N is the total number that we were selecting from. So I saw that we had 50 tickets in the box, so my n will equal 50. R is literally just how many am I going to select out of that total. We're only going to draw 3 winning tickets, so my R will equal 3. Now we'll just plug it in. So this will equal, everywhere my n is, we'll get a 50. 50 factorial divided by, that's my R, 3 factorial, parentheses, n minus r, so 50 minus 3, and the factorial goes on the outside. And now we're going to simplify that down before we head to the calculator. So this will still be 50 factorial divided by 3 factorial times 50 minus 3 is 47 factorial. Now we're ready to go to the calculator. So hopefully you paused the video and you went to your own calculator and you should have gotten an answer of 19,600. There were 19,600 different combinations that could have made up those 3 winning students.
All right, guys, one last example. And once again, the biggest challenge with these problems is deciding, does the order matter? With combinations, the order does not matter. And with permutations, the order does matter. So let's take a look at this problem. It says you will draw winners from a total of 25 tickets in a raffle. The first ticket wins 100, the second ticket wins 50, and the third ticket wins 10. In how many ways can you draw the 3 winning tickets? So I want you guys to think, does the first place, second place, and third place, does order matter here? And you should, when we look at this problem, you should realize that the order does matter, right? You would much rather be the first ticket drawn because that person wins $100 instead of just 10, right? So the order does matter here, okay? If the order matters, that means that this is a permutation. So we're going to use this equation here. To find a permutation, we use n factorial divided by n minus r factorial. N is just the total number here. It says that there's a total of 25 tickets. So we're going to use 25 for n. Okay, and it says that we're drawing 3 tickets, right? The first place wins 100, second wins 50, and third wins 10. Okay, and before we go to our calculator, we're going to simplify this down a little bit. 25 factorial divided by 22 factorial. And now we'll go to our calculator to solve.
3.
And after we calculate, we find that our answer is 13800. So there are 13,800 ways that you can pick the winners from those 25 tickets. And one quick thing before we move on here, there are a couple pieces of information. Did we use this $100, $10, or $20 or $50? Did we use those numbers in our calculations? We didn't, okay? So you need to think real hard. The only things we need here are the total and how many we select.